Hey guys, welcome back to Business Statistics. This is sections 7.4 and 7.5, interval estimate and sample size requirements for estimating the population proportion. Okay, before we get into any definitions, this is now going to be something where we're estimating a population proportion. So we're not estimating mu. So the point of the confidence interval is not to kind of triangulate mu, it's not to try to predict mu in any capacity. This is to try to predict P or rho, as it's called. So what would be the true population proportion? Okay, so this would be used when we're talking about things that are like binary examples, like preferences, ratios, that sort of thing. So it's used when, let's get into the definition. Definition of the term proportion, notations for population proportion, refers to fraction, ratio, or percent of population having a particular trait of interest. Okay, so what would be a trait of interest? A proportion of people voting for somebody, right? Like that's like the most obvious and topical example, so in fact, as I'm recording this video, tomorrow is election day. So tomorrow is election day, and we just had a huge election, obviously, last year in 2016. But so rho, the actual population proportion, we're going to be trying to predict. Okay, so this is not a mean, this is not an average, anything like that. This is going to be a proportion of something, more than likely a proportion of people's opinions, or a proportion of some sort of trait that people have, or something like that. Okay, I think that's generally the examples that you're going to see as well. Okay, so then the formula for the population proportion is just called p hat. All right, so that this little symbol here is that's an arrow over it. It's called p hat, and that's just equal to x over n. Okay, so n would be the number that is sampled, and then x would be the number of, I guess you'd call them positive responses, right? So, are you voting for the Democrat, or are you voting for the Republican? Whatever you view as the positive response in that capacity. So, like, say you have 500 people that you're polling. And actually, I think we're going to get into this very example here in a little bit, and say them voting for a particular candidate is labeled as sort of a success, right? So then the number of people that actually voted for that candidate is your X, and then the number of people that are surveyed would then be your N. Okay, so it's just your sample proportion. That's all. Now that can obviously be used to estimate rho or P, okay, which is the population proportion. But we're obviously going to look in and see how we can turn it into a confidence interval to give us some level of certainty that an answer is within a certain range. Okay, just in the same way that we did with the Z confidence interval and the T confidence interval. Okay, the sampling distribution of the sample proportion p hat is approximately normally distributed. The confidence interval formula is below. It's p hat plus or minus z alpha half times the square root of p hat times 1 minus p hat over n. Okay, so that's your formula. The expected value mean for p hat is the population proportion p, or rho. And then the formula for estimating the sample size for the population proportion, meaning if we want to be so confident, how big of a sample size do we need to have? Okay, so that answers that question. So n is equal to p times 1 minus p times z alpha half over the margin of error squared. That's answering the question, how big of a sample do we need in order to be 95% confident, in order to be 99% confident, that sort of thing. Okay, so let's get right into it. Example 6, the Chamber of Commerce of a mid-sized city has supported a proposal to change the zoning laws for a new part of town. The new regulations would allow for mixed commercial and residential development. The vote on the measure is scheduled for 3 weeks from today, and the president of the Chamber of Commerce is concerned that they may not have the majority vote that they need to pass the measure. She commissions a survey that asks likely voters if they plan to vote for the measure. Of the 516 people selected at random from likely voters, 289 said they would likely vote for the measure. Find the 99% confidence interval for the proportion of voters who will vote for the measure. Okay, so as is the case always, let's write down the information that we have. Okay, so we have an N that is equal to 516. It's the number of people that are surveyed. An X value, the number of people who are voting for the measure, of 289. And what else do we have? We have a 99% confidence interval. Okay. And then this 99 implies alpha equals 0.01. Okay. All right. It's asking us find the 99% confidence interval. So we go ahead and we write out our confidence interval formula. P hat plus or minus Z alpha half times the square root of P hat times 1 minus P hat all over N. So let's just run through our formula and see what we have. Do we have P hat? Sort of, I guess, right? We know the formula for P hat, and we have the two components of that. We have the X and we have the N. So let's go ahead and write that in. So P hat is equal to X over N, which is equal to 289 over 516, which is equal to 0.56. Okay. So yes, we have P hat. Do we have Z alpha half? We don't, but we can find it, right? We have this P hat, we have that P hat, and we have this N. Okay. So the only thing we need now is Z alpha half. All right. So we know what alpha is, though, right? So our alpha half is 0.005. Okay. So let's go find Z alpha half in our table. Okay, we go back up to the Z table now because our population proportion uses that. And our Z alpha half of 0.005. So we're going down the table here. We're looking for something that looks like 0.005. Okay, now we pass it. We can see that the values are getting smaller. Looking for 0.005. And right here we pass it here at 0.0049. Perfect. So negative 2.58. So negative 2.58 is our number. Okay. Or 2.58. Remember, it doesn't matter because we're plugging this into a plus or minus, so it's always really, you just always use the positive one. All right, so we have all of the components for our formula. All right, so we have 0.56 plus or minus 2.58 times 0.56, 1 minus 0.56, which is 0.44, divided by n, which is 516, and this whole thing, square root. Okay, so what does that equal? That equals it equals 0.503 to 0.617. Yeah, and I'm just not gonna go through kind of the arithmetic of it. I expect that you guys know how to do that, but it's also just kind of a nice check for you to, walk through it yourself. All right. Okay, so next example. So that was us doing our confidence interval. So again, what does this confidence interval mean? 0.503 to 0.617. This is where we have 99% confidence that our actual proportion of voters is in this range. So what does that actually mean, though, in terms of the problem? Looks like this thing is going to pass. because we're 99% that it's greater than 50%, right? If you just need over half the people to vote for this thing, well, we are 99% that the proportion is in this area of 0.503 to 0.617. Well, that's pretty good. We're 99% sure that it's in this range, and this range is above 50%. Okay? So that's their interpretation right there. All right, example 7. According to the Statistical Abstract of the United States, the percentage of people not covered by health care insurance in 2003 is increasing. Wow, this is old information. A congressional committee has been charged with conducting a sample survey to obtain more current information. Ah, I see. What sample size would you recommend if the committee's goal is to estimate the current proportion of individuals without health care insurance with a margin of 0.03 use a 90% confidence interval? Okay, so what do we know? First of all, we know we're looking for a sample size. Okay, because we know we're looking for a sample size, we know that our formula is equal to n times p, or n is equal to p times 1 minus p times z alpha half over e squared. All right, so what information do we have? I see that we have an e here. We have a margin of error equal to 0.03. And I see that we have confidence interval equal to 90, or we have a confidence level equal to 90%. Okay, so confidence interval, confidence level, they both can imply alpha. Okay, and so then alpha is 0.10. So then alpha half is 0.05. Okay, so that's that. So what do we have? I don't see us having a p here. Well, that's not good. Okay, so this is a very important lesson. When you are not given a p, which p should you use? And I'm not going to get into the mathematical explanation as to why this is the case, because I think I just don't want to get into that. It's a fairly easy example. It has to do with a square. It has to do with the shape, actually, and calculating an area of a square versus an area of a rectangle. And I'll let you just kind of ponder what that means. But when you are not given something and you want to maximize, the p that you're just going to resort to is 0.5. Okay, so if you're not given a p in a scenario like this, you just assume that the p is 0.5. Okay, the reason why, because that is going to maximize this term. So that times 1 minus p is going to be maximized, thus giving us the largest n possible with a p equal 0.5. You can check it if you want. You can assume p equal 0.7 and then run the numbers. You're always going to get a smaller number. But if we want to be sure in this scenario of this problem, we need to be using the p-value that yields the largest n value. Okay, so we're going to look at a formula. What do we have? We have an e, right? We have a margin of error. Now we've created a p that we're going to be using, and z alpha half, which we can go find. So z alpha half, or z of 0.05, is equal to what? So let's look. So we're on to our z table. And we're just looking for 0.05. We passed it down here, so we're going to look. 0.05. Okay, it looks like we are at 1.65. 1.65. All right, so we go ahead and put that here, 1.65. And then we can just plug into our formula. So n is equal to 0.5 times 1 minus 0.5, which is also 0.5, times z alpha half, which is 1.65, divided by our margin of error, 0.03, whole thing squared. Okay, so you go ahead and run those numbers, and we get 756.25, which, if we are looking for the minimum number of n values, we're always going to round up here, as mentioned in a previous video, 757. So this is the sample size for which we'll have 90% confidence that we'll be able to estimate the current population within a margin of error of 0.03. Okay, so we're saying that we're going to have a confidence interval that is 0.03 away from p hat on the top end, 0.03 away from p hat on the bottom end. This is the sample size that we need to estimate that interval with 90% confidence. All right, thanks so much, guys. Please let me know if you have questions. Hit me up via email or on the discussion forum. Anything to get your questions answered, okay? All right, thanks so much. Till next time.